here we go. All right, the rate of change, of the temperature, of an object is proportional to the difference the rate of change of the temperature of an object is proportional to the difference between the object's temperature and the temperature of its surroundings. So this one I think is interesting because this formula is talking about the rate of change of the temperature of something when you put it into like room temperature. So like if you had like a 2 liter of soda and you take it out of the fridge and you stick it in a room, how quickly is it gonna like come to that room temperature? And it's based on like how cold was it in the fridge? What is the room temperature? There's like formulas for that based on differential equations because calculus talks about the rate of change of something, right? So there's a formula for like how quickly that temperature is gonna change. Does that make sense? I think this is one of the things you actually care about. Like, so if you were like a super nerd, you could actually sit there and calculate. You're like, I'm going to have a party and I'm going to take the 2 liters out of the fridge. And how long can they sit on the table before they are too warm to drink? You know what I'm saying? Would anyone actually do that? That is very rude, but also a very good point. Okay, we're going to move on. So, we're going to say d capital T dt, so the change of temperature over time. So capital T is going to be temperature. The change of temperature over time is this is your growth rate, right? Times T minus S, capital T minus S. So T is the temperature of the object, S is the temperature of the surroundings. Does that make sense? Okay, so off to the side, I'm going to write T of T. So this is going to be the temperature of the object as a function of time. That's why it's capital T of lowercase t. The temperature of the object as a function of time. Does that make sense? So instead of like f of x, a function of x, right? Capital T of lowercase t. So your input is time, your output is the temperature of the object. Does that make sense? Okay. S is going to be the temperature, here let me, of object. S is the temperature of the surroundings. Temperature of the surroundings. Okay. All right, so let's do this little proof here so we can have the formula written down. So this is a differential equation. We're going to separate our variables. So we have the variable t, we have the variable s, okay? Or not the variable s, we have the variable t, we have the variable t, uppercase T, lowercase t. So think dy dx, but capital T, lowercase t. Make sense? Okay, so we're going to separate things. We're going to move things left side, right side. So what is going to move to the left side? What is going to stay on the right side? Think of this as dy dx. We're going to divide by t minus s. Okay, so minus s, we're going to divide it over. So we're going to have 1 over t minus s, d capital T, equals, and we're going to leave the k here because, again, that's just a number. And then we're going to have d lowercase t. So you guys see the dy here, and then the dx there. You guys see how, so we've taken a differential equation, we have separated it. Okay, so now what do we do? Integral, yeah. Integrate both sides, because we're trying to solve for the equation. We want to end up with an equation that is a function of t, okay? Capital T function of lowercase t, okay. All right, so this is technically a U substitution problem, so I'm just gonna do a good job showing my work, okay? So U is capital T minus S. The derivative of U is what? What's the derivative of T? Just dt. Okay, because the S, it's kind of like saying T minus 7, T minus 5, T minus -1, T minus a number, okay? All right, so when we integrate this, we're going to say that we are integrating 1 over U du. That's what we're integrating. Okay, so what do we get when we integrate that? ln u. And so what do we actually have? We have ln of t minus s. Okay, equals. What do we have on the other side? kt plus c. Okay. Are we comfortable so far? Yes. Okay. Now, when we do the process of solving separable differential equations, what is our goal? To get the, we want to solve for c, right? We want to take an initial value and solve for c, and then what else do we want to do? We want to get something alone, which would be the capital T. So we want to get the y alone, which would be the capital T. Okay, so let's go ahead and start working on getting the capital T alone, which means we need to get rid of the ln. How do we do that? Okay, so we're going to e both sides. We're going to x sides by adding a base of e. It's a big word, we know it. ln equals, and what do we end up with? Okay, ce to the kt. Okay, and what do we end up with on the left side? Okay, t minus s. Okay, and then how can we get capital T alone? Okay, add s. Okay, so capital T equals ce to the kt plus s. Okay. Capital T alone. Okay. So now we need to think about how we could get rid of some of these letters that are representing constants. So we have lowercase t is the only letter in here that is actually a variable. Everything else represents a constant, okay? So if we had an initial value, we would be plugging in 0 for lowercase t. Would you agree with that? If we have an initial value, lowercase t equals 0. So I'm going to go ahead and write that down. We're going to say initial value, lowercase t equals 0. So what I'm going to do is I'm going to plug that in and just see what happens. So t of 0 equals e to the k times 0 plus s. Are we comfortable with that? Okay. And so now if we simplify that, what happens? C plus S, okay? Now, capital T of 0, we're going to call this T sub 0. You've probably seen in your science classes. Is that accurate? Science classes, we've seen notation like that to represent initial values. We've seen it a little bit in math, not as much, T sub 0, T sub 1, okay? So what we're going to do is we're going to say, okay, my T sub 0 equals C plus S. So now, don't restart right now, computer. No, not now. No. Okay. So one of the things we can do is we can solve for C in the front, okay? Because in these problems, think about the problems that we were doing yesterday. Sometimes we had an initial value that they would give us in the problem, right? And so if we think about how these problems are going to go, is like, okay, we could picture them giving us an initial value, and we can picture that the temperature of an object versus like the temperature of the surroundings, they're probably going to give us an S. Does that make sense? We can isolate our formula to have a T sub 0 in the formula and have an S in the formula. But if we can get rid of the C, that would probably be helpful. Make sense? So what we're going to do is we're going to subtract the S over. Minus S minus S. So we have T sub 0 minus S equals C. Does that make sense? And so what we're going to do is we're going to take this C and we're going to remove it and we're going to replace it with T sub 0 minus S, because that's probably what they're going to give us in the problem. They're probably going to give us an initial value. They're probably going to give us surrounding temperature. Temperature in the room is 75 degrees. The temperature outside is 62 degrees. So they're mentioning about the temperature of an object and the temperature of the surroundings. So it makes sense for the temperature of the surroundings to be given in the problem. Do you guys see how that would work? Okay. So C is comprised of that initial value and the surrounding temperature. So all we're doing is we're just solving for C in the formula so that we don't have to solve for it in every single problem. Does that make sense? Okay. So T, as a function of T, you can put the of T or not, it doesn't really matter, equals T sub 0 plus E to the KT plus S. That's the formula that we're going to use. And this work is with it.
So is the T sub 0 like the initial value?
Yes. Yeah. Where T sub 0 is the initial value. And this T over here is going to be the temperature of the object after you're done with the time, after whatever time you have. Okay? Right. So here is an example problem. A 2-liter bottle of soda at room temperature, 70 degrees Fahrenheit, placed in a fridge, 38 degrees Fahrenheit. After half an hour, the soda's temperature is 61 degrees. What is the temperature after another half hour? How long does it take for the soda to cool to 50 degrees? That is a lot of temperatures. Okay, so let's unpack this a little bit. Okay, so what is, let's see here. We're going to say the temperature of the object is what? Can you tell what the object is? Soda. Okay, so the soda is the object. What is the temperature of the object? 70 degrees. Okay, so that's capital T. All right, what is the temperature of the surroundings? 38 degrees. That's your surroundings. Okay, do you guys see how that works? Okay. After half an hour, the soda's temperature is 61. So now we've got a point. We have an input of time and an output of a new temperature. You guys see how that works? An input of time, an output of a new temperature. Okay, so let's write this down as a point. Input of time, output of a new temperature. Actually, so I'm going to write this. We have a starting, this is the initial value, T sub 0 was 70. Okay, so let's write down our point. What was the time input, and then what was the output temperature? Okay, half an hour, input of time. What's the output temperature? 61 degrees, okay. And then what's the question that we're solving for? We have another point they want us to get, and what's the new point they want us to get? Okay, after another half hour, so at 1 temperature, okay. And then what's the other point they want us to get after that? Okay, how long does it take to cool to 50 degrees? All right, do you guys see how all that information is given us in that problem? Okay, so we're comfortable with that. Okay, so what I'm going to do is I'm going to write down the formula. Capital T equals T sub 0 minus S e to the kt plus S. And thinking about yesterday, what is the first thing we typically needed to solve for? The K. We typically need the K. And in this problem, they don't talk about the proportionality, growth, constant, whatever. They don't talk about that at all. Okay? So we do have a T sub 0, we do an S, we do have a lowercase t, we do have a capital T, which means we have everything we need to come up with a K value. Okay? So let's go ahead and plug all the stuff in. So we have an initial value for the soda of 70 degrees. We have roundings of 38 degrees. We know after 1/2 hour, the temperature is 61 degrees. We know that we're solving for K, and then we also plug in 38 over here. Okay, we comfortable? Okay, so let's go ahead and start number crunching. I'm feeling a little bit lazy, so I'm going to use my calculator to help me a little bit with my number crunching. So what should I do first? Okay. So 38 is almost 40. So 61 would be 21. 23. 2 less than 40. So 20. I don't trust my brain today. 23. Okay. 70 minus 40 is 30. 32. Sorry. Okay. Now what should I do? Okay. And then what should I do? And then what should I do? That's very annoying. My waffle does not even make sense. No, I haven't had a waffle every day for breakfast for like 5 years now. I have. So I don't even put my waffle maker away. That's how serious I am about it. So every time my friends come over, well, now they'd be like, why don't you put why is your waffle maker always out? And I'm like, because I have a waffle every day. Why would you put it away if you literally have one every day? It just has a permanent place on your, huh? No. I put peanut butter. No, not plain. I have a waffle and put crunchy peanut butter and syrup on top. That's one of my options. My other option is I do cream cheese and then raspberry jam on top. They're both delicious. Don't sleep on it. 5 years. I love me some waffles. If your breakfast is delicious, you can have it for 5 years. And sometimes, listen to this, sometimes I have a waffle for dinner too. All right, let's move on. So our formula is T equals, we're going to keep the 70 minus 38 because that's going to just work for all the problems. So 32 is a coefficient, I'm going to keep going. So 32e to the 2 ln 23 over 32 lowercase t plus 38. So that is the formula that we are using for this particular problem. And now we can do the rest of what they were asking. Now we can answer the two questions. Does it make sense? Yep, plug in 1 for t to figure out what the output is, and then after that we'll plug in 50 for uppercase T, capital T. Yeah, so we'll do the first question. So t of 1 I forgot that it was a new semester and I have to train my Math 3 kids all over again. Because I'm getting students who are like, oh, I watched the notes but I didn't write anything. That was literally my exact response. I was like, I don't understand. Or they'll start watching the notes in class, have headphones in, and they're just watching it, there's no sound. And I'm like, tell me again how you're learning? Right? No, they don't. No, they don't. No, they don't. But they think that it's reasonable to do that. I'm like, what makes you think that watching the notes without sound is acceptable? Yeah, so I'm being reminded that I need to explain, that I have to like start my explanations again. Oh, all right, what answer are we getting? Okay, perfect. And then what are the units on this? Degrees Fahrenheit. Marvelous. Okay. 1. What do we do for the other one? Okay. 50 equals 2 e to the 2 ln She's going to teach them about life. All right, what are you guys getting for tea? I typed it in like a fraction and I typed it just like this. I got 1 point something. Did you put the 2 on the bottom? I did alpha y equals so I could have a fraction, a whole fraction, remember? Like this. I typed it in like this. So I could type it in exactly the way it looked on my paper. You guys, look, I did my change of base again. Isn't that wild? Logs are so weird. I want to know why that works. I don't want to know why it works. It's magic. It's wild. Okay. 1.485. Make sure you can get it on the calculator. What are the units on this one? Hours. I'm not going to write a sentence because I don't feel like it. Okay. Did we get it? Yes? Okay. The next one is going to bring back real good memories for Math 3. That's good, you guys. All right, the compound interest formula. You could do A equals or Y equals, it doesn't matter. The final amount. I'm just going to give you straight up this formula. This is not really, this is not calculus, okay? So A equals the principal amount. So this is the final amount. The is 1 plus r over n to the nt. The R is the rate, the interest rate written as a decimal. So if it's 5%, you write 0.05. The N is the number of times the interest is compounded per year. So if it says quarterly, it's 4. If it says monthly, it's 12. If it says semi-annually, that is 2. If it says weekly, that's 52, that sort of thing. And then we have the compounded continuously formula, which is A or Y. Again, it doesn't really matter. Most people say Y. Y equals PE to the RT. PERT. And PERT can be, what's the word? Estimated, approximated, using the limit as n goes to infinity of 1 plus r over n to the nt. So this is the same as e to the rt. So I guess the 1 plus r over n, this is the same as e. That blows my mind. I don't know. It blows my mind. So as n goes to infinity, I don't know. It's wild. I think it's wild. I don't know why it works, but it does. Check. You don't have to write this. But you can't. But you can't. Did you start to write it? That's wonderful. All right. All right. So dollars in a CD, which is a certificate of deposit account, for 3 years at 6% interest. That is very high. You would be lucky to get that. I think interest rates are like 0.25%. Right? There you go. They have dropped since I've last seen them. Find the total amount of money in the CD if so we are going to do 4 equations: yearly, quarterly, a monthly. I spelled month long. Oh, monthly. I did not. I spelled it correct. That was on the way. Monthly, continuously. Okay. So our final amount, if we invest $1,000, that's our principal. We have 1 plus 0.06. What is the n value if your interest, goodness gracious, I can speak, I swear. What is the n value if the interest is compounded yearly? 1, just once a year. So the 1 times 3. Okay, so we're going to type this in. 1,000 times 1 plus 0.06 over 1 to the 1 times 3. Okay, we get $1,191.02. Okay, quarterly, 1,000, 1 plus 0.06, and then what would we put for quarterly? 4. Okay. So we're going to change this to a 4. Okay. And we get $1,195.62. Okay. Monthly. What should we put? 12. And what do we get? $1,196.68. You get a whole dollar more. Okay. And then continuously, a 1,000 e to the 0.06 times 3. That one's just totally different. 1,000 e to the 0.06 times 3. 1197.22. All right. When you're looking at how often your interest is compounded. Continuous. The more the better, right? The more often, the more money you're going to get from interest. All right. So at this point, we are just finishing the 4 problems we did not get to yesterday. So I think it was 13, 15, 19, and then the last one on the worksheet. Did I remember correctly? I don't know. Who knows? It's on Canvas. Let me pull up Canvas. Yes.